So our last method here is by far the most logistically dense, the most complicated method. It's also the most mathematical. I guess those go hand in hand. Hopefully you guys don't make that connection just for yourself, though, because I'd like to think we've demystified a little bit of math in this class. Anyway, here for the pairwise comparison method, what we do is guarantee that we get the option that's the most satisfying in terms of head-to-head runs, because we compare each option head-to-head in terms of the numbers of votes that it got. Where to get the number of comparisons we have to make, we call that C. We have N for N different ballots, N different ballot arrangements, times N minus 1 over 2, where in particular, that's a value called N choose 2. For those of you that maybe have taken stats, there's also a little bit earlier on in this book that talks about it that we skipped over here. That's included in the other half of this class, but don't worry too much about that. We're keeping that formula as it is. Anyway, what we're going to do for this method follows a few steps where we will rank all the voters with the results summarized by a preference table. Then, the table is used to make a series of comparisons in which each candidate is compared to each of the others. From there, for each pair, use the table to determine how many voters prefer one to the other, x to y or y to x. If a majority prefer x to y, then x gets a point. If they tie, then each gets half a point. And then after all the comparisons are made, we count up all of the ones to determine who is the winner. So in this case, we want to talk about that vacation vote. We want to talk about that European vacation for our context here. We will end up making, in this case, C equals 4 times 4 minus 1 over 2 equals 6 comparisons, because we have 4 different cities we can go to. I misspoke there when I said ballot options. I should have said options on the ballot. And what we're going to do then is compare each of our cities pairwise, just like the name says. So we're going to go through each of those and see who wins head-to-head across the ballots. For Paris versus Rome, we're going to go through each of these columns, each of these ballot arrangements, and determine how many of them was won by Paris, how many of them would be won by Rome. That is, how many would be preferred. So in the first 14, Paris is the first choice, Paris wins those. In the second, with those 10, Rome is second, Paris is fourth. Even though neither of them was the preferred choice, they definitely prefer Rome to Paris, so Rome gets those 10. Then in the third, we have that Rome is third, Paris is fourth. Nobody wants to go to Western Europe in that case, but they would rather go to Rome over Paris, so Rome gets that 8. For the fourth group of 4, Rome was first, Paris was last, so Rome very clearly gets those 4 votes. And then in the last case, we have Rome and Paris on the bottom again, where we have that Rome would get that vote. So we end up with Rome having 23 votes to Paris's 14 that it won, which means Rome gets the point there. For Paris versus Saint Petersburg, again, Paris wins the first. Then Saint Petersburg wins all of the other 4 because, again, Paris is the least popular for everybody except those who really want it. So, for exactly the same reason, St. Petersburg wins that point. Then we compare Paris to Tallinn. Again, Tallinn wins despite its arrangement not being exactly the same as Rome and St. Petersburg. It's still more popular with the 23 people who don't want to go to Paris. Then from there, we've got 3 more. For Rome versus St. Petersburg, Rome second, St. Petersburg third, means Rome gets 13. Then St. Petersburg first, Rome second, means St. Petersburg gets 10. Then it is 8 for St. Petersburg, 4 for Rome, and 1 for St. Petersburg. So St. Petersburg just barely gets the majority there with 19. For St. Petersburg versus Tallinn, we have that St. Petersburg wins the first 14 and the second 10 and the last 1, while Tallinn wins the middle 8 and 4. So, St. Petersburg gets 25 to 12 for its point there. And then finally, for Rome versus Tallinn, we have that Rome gets the first 14 and the second 10, while Tallinn gets the middle 8 and the last 1, and then the last 4 also, that fourth 4 also go to Rome. So Rome very easily wins that vote 28-9 to get another point. Where, in this case, looking at all of these various options, we have that Saint Petersburg gets 3 points, while Rome will have gotten 2, which means that Saint Petersburg got the majority, so that would be the one that won via the pairwise comparison method. And looking at these 4 elections using the exact same ballots, we got 4 different results. So which one's the best? I guess that depends on which city you want to go to. But more reasonably, more thoughtfully than that, what we can do is talk about what makes a given election scheme fair, or for that matter, unfair. And that's what we'll see in section 13.2, where we see the flaws in these schemes that we have, the ways that they may or may not end up providing a reasonable result.